Express these numbers, 48 and 72, as products, that means multiply, of prime factors. Okay, so it doesn't say which way you want to do it. Do you like the table method or do you like the tree method? I'll do the tree method because I've found most people prefer that way. Okay, 48, can I break that thing down? You got lots of choices, right? Is it 12 times 4? Is it something else? 4 times 12. Okay, can I break down 4 or is that a prime number? You can break it down. You keep going until you get prime factors. That's 2 times 2. That's 4 times 3 is one option. And 4 is 2 times 2. So if I multiply 2 times 2 times 2 times 2 times 3, I get 48. Okay? That's a product of its prime factors. Just prime factorize it. That's what I did with this tree. Okay, don't try to guess. Well, it could be, is it 5? No. 3 times what? I don't know. Just do that and you're done. Okay, there's the answer. 72. I'll do this over here. Okay, what do I want to take out of there? Do you know your times table well? Or do you want to start with a 2? I don't know my times table. I'll just take 2 out. I think I remember 36. That was 6 times 6. All right. And those aren't prime numbers yet. That's 3 times 2, 3 times 2. And I think I'm done. Are those all prime numbers? Yeah, they're all 2s and 3s. So 72 as a product of its prime factors is 2 times 3 times 2 times 3 times 2. Okay, let's check. 6 times 2 is 12, times 3 is 36, times 2 is in fact 72. All right, now we're going to take this one step further. Applications of prime factors. Okay, yesterday you got a little skill. You hopefully could prime factorize these numbers. Why, you ask? Where am I going to use this in the real world? Well, you're going to use it today because we have some terminology for you. Greatest common factor, or short, GCF. I don't know if they will abbreviate that on the government exam, but it's worth memorizing. They might, okay? You can't ask anybody if you see GCF what that is. You got to stick it in your noodle, okay? Greatest common factor. So you guys know what factors are? What are the factors of 6, Kelvin? Those are prime factors. Are there other factors? All the factors of 6. Does 1 go into 6? Yeah, okay. 6 goes into 6, and we have the prime ones, 2 and 3. My pen's doing strange things. Gets a little bit of static electricity, and then it goes, okay? Those are the factors of 6. Doesn't say prime here, just says factors. Now, if we have 2 numbers, let's say I have a 12. There's all the factors of 12. Those are all the numbers that go into 12. What's common between these 2 factors? Well, they both have a 1. They both have a 2. They both have a 3. They both have a 6. Okay? So now I join these 2 words. There's the factors. Those are the common ones. Now, which one's the greatest? It's only going to be one answer. Okay? That's 6 is the greatest common factor between 6 and 12. Okay? Here's the definition of it. It's the set of whole numbers is the largest whole number which divides exactly into each of the members of the set. Doesn't say pair of numbers because you're going to get 3 numbers, maybe even 4. What's the greatest common factor? And sometimes you can see it. If your numeracy is pretty good, you can just see what it is. Some of you guys probably see the answer to this already. If you can't, then you got to do this stuff. We're going to show you how to do it between numbers like, I don't know, 48 and 112. Do you know what the greatest common factor is? No. Okay? Maybe you do, but take you a minute. We'll show you a way to do that. Okay. So 8, 16, and 20. Let's do this. 8 is 1. 2 is a factor. Does 3 go into 8? 4? Yep. 6? No. 8? Okay. 16. 1, 2, 4, and 8, and, of course, 16. 20. 1 goes in there. 2 goes in there. 4 goes in there. Does 5? Yeah, 4 times. 6? Nope. 7? Nope. 8? Nope. 10. 20. What are common? These are common. What's my greatest common factor? It is 4. If you saw that already, great. Okay? But if you don't, then you do this. You write it out. Okay? So it's, in layman's terms, it's the biggest number that goes into each one of the numbers they're asking you to do. Okay? Hopefully you only have 2. But like I said, we might give you 4 numbers, which is the biggest number that goes into those numbers. Okay? That's greatest common factor. Do we see what this one is? What's the largest number that goes into 15 and 25 and 35? Some of us see it. Does everyone agree? When I ask a question like that too, try not to like yell it out quickly, okay? Because other people, that ruins their thinking. And thinking is how we learn. Okay? So if you see the answer, put up your hand, okay? I'll, probably ask you. Does everyone agree with Calvin? Is 5 the biggest one that goes into all 3? Yeah, okay? You can't find another number bigger than 5 that goes into these 3 numbers evenly. All right? 18 and 20. Does 2 go into both of those? Sure. Is there something bigger? Like what? What goes into 18? Well, 1 does, 2 does. Does 3? Yeah, 6 times. Okay, 4? No. 4 times 4 is 16. 4 times 5 is 25. Nope. 6? Yeah, 3 times, right? 8, 10, 12. I think that's it, right? Oh, 9. 9 does. And, of course, 18. Now remember, this is kind of helpful. These pair up, don't they? 18 is 18 times 1. It's 2 times 9. It's 6 times 3. And that's it. Now, maybe I don't need to do 20. Let's just look at these numbers. Which is the largest one that goes into 20? 18 doesn't. 9 doesn't. 6 doesn't. 3 doesn't. Looks like it's 2. Okay, seems pretty small. But try as you like, you're not going to find a bigger number that goes into both of those. Okay, and they get a little bit harder. 36, let's just do that one. 2 goes in there 18 times. Come on, pen. Does 3 go in there? Yep. 12 times. Does 6 go in there? Yep. 6 times. Does 4 go in 36? Yeah. Forgot that one. 9 times. And that's probably it. Which is the largest one that goes into 54? You start here. Does 36 go in 54? I don't know. Because, it's early, right? And I got a calculator, and let's use it. Because some of you guys, your numeracy is not as good as other people. You're going to do this. You want the right answer, right? Okay? It's good to have mental math. And like I said, some of these questions, you're not going to have a calculator in the government exam. But you have it. Use it. All right? So no. Does 18 go in there? 54 divided by 18. There's one way to find out. Ooh, look at that. It does. 3 times. Okay? So that's 18. Okay? So this is what I'm doing here. I'm doing prime factorization to find it. I want to see what the number is. Some of us are better than this than others. If you see it, great. If you don't, then you're going to write it out. Okay? Here's the numbers. Here's those numbers. What's the greatest common factor? Well, here's a little trick. If we prime factorize this, and they didn't do it as a tree, okay? I prefer to do this as a tree, but there's no room here. We go, what's common in both two groups? I got a 2. Let's write down a 2. Times, do I have another 2? Yes, I do. Do I have a third 2 in both groups? Yes, I do. Do I have a fourth 2? No, I don't. Okay, but do I have a 3? Yes, I do. And I'm done. That's all the numbers that are common in both groups. My greatest common factor is 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay? So that's why we're teaching you prime factorization, because it can help to find the greatest common factor. Okay? Because they're not always going to be nice ones where we can see it. That's getting a little tricky. 90 and 225. Anyone see what the greatest common factor is? Because I don't. Okay, use prime factorization. 90. Let's go 9. Come on, pen. Times 10. Okay? You keep going until they're prime numbers. That's 3 times 3, I'm done. That's 5 times 2, I'm done. What do you want to take out of 225 to try to break it down? Does it end with a 0 or a 5? Then 5 goes into it. Let's start there. Okay, 5 goes in there how many times? 5 goes into 200 40 times, and 5 goes into 25 5 times, so that's 5 times 45. This is prime, I can stop there, but 45, let's take out another 5, and 9 we can break down into 3 times 3. So how do I find my greatest common factor? What's common in both two groups? Okay, my greatest common factor is, there's a 3, there's a 3. Write it down. Okay, multiplied by, what else is common? There's a 3, there's a 3. Do you notice I'm circling as I'm going? That way you're not going to count the same number twice if you're a messy writer, like Bryce. All right, is there any others that are common in both two groups? Yep, I got a 5 there, I got a 5 there. It doesn't matter which one you take. Is there any other numbers, prime factors, that are common in both two groups here? No, I'm done. My greatest common factor is 9 times 5, 45. Okay, if you saw that right off the bat, good for you. You're better than I am, all right? And if you saw the last one, I'm sure you don't see this one, okay? Let's break them down. What do you want to take out of that? You see anything that goes into that? I don't. Let's start with 2. Okay, let's half of that. What's that? That's not 80, that's 77. 77 times 2 is 154, right? 77, how do we want to break that down? 7 times 11, that's our multiplication table. Are those all prime numbers? Yep, I'm done. Okay, 198, let's half it. That's 2 less than 200. Half of 200 is 100. So that's got to be 2 times 99. 99 is that also our 11 times table? 11 times 9. Are those all prime? 9 is 3 times 3. How do I find my greatest common factor? I find all the numbers in both groups that are common. Let's go red. 2 is common to both groups. Times What else do I have? 11. Any others? My greatest common factor is 22. Okay? Any questions so far? That's why we prime factorize. Who wants to do that one? Okay, I'm not going to give you something that big and ugly on the test, but, you know, don't quote me. I might. But for now, I don't know if that helps us. Let's just do this guy. Okay, 245. Where do we start? What goes into that? How do we prime factorize it? Take a 5 out. Okay, let's not kill ourselves. Okay, how many times does 5 go in there? Okay, if you don't know, then you pull out your calculator, right? 245 divided by 5, 49, okay? And 49 is 7 times 7. Hey, we're done. That wasn't too bad. It's only 3 numbers. Now, when they're bunched like this, don't, like I have colors here to tell the difference. You got to be neat and clear. You have to see, right? If it helps, maybe do a line like that to keep these separate. Let's just take a 5 out of there. What's 315 divided by 5? 63. Okay, 5's done. 63. Does something go into 63? Sorry? 3? That's on our times table, sure. I like 9 times 7. 3 definitely does. We all get to the same place. Doesn't matter. Okay, 315 is 5 times 3 times 3 times 7. Doesn't matter how you break it down. We should all have the same answer there. Finally, 770. What do you want to take out of there? Yeah, I was going to say, you know, most people, well, it ends with a 0 and or a 5. Take a 5 out, but let's make it a little bit bigger. It just makes our tree a little wider and a little less long. Because sometimes they don't give you a lot of room to work here. So 10 times 77 is 770. 10 is 5 times 2. 77 is 7 times 11. And are we done? Okay. How do I find my greatest common factor? Who will tell me the procedure? Who's got it? What do I do? Some of you know it. You're just not putting your hand up. Except Alicia. What do we do, Alicia? Yep. Okay. So it doesn't matter where you know what? Let's start on the right. Let's go Chinese and read from right to left. 7. Do I have a 7 in all 3 groups? Yeah. Circle it, guys. Because this is looking pretty messy, and I got 3 different colors here. If you're using all the same color, like pencil, you got to be really neat, or you're going to get the wrong answer. Okay? What else? 11. Do I have 11 everywhere? No. 2. Do I have a 2? No. 5. Okay. 5, 5, and a 5 there. And that looks like it's it. My greatest common factor is 35. Okay? Could you check this? Like, if this is a test and I'm done, you know, and I looked over everything and I got 20 minutes to go before the bell, what should you do? Pull out your calculator and go 245 divided by 35. Make sure it works, first of all. Okay, so yeah, 7 times. Try each of these. Make sure that at least that number goes in them. You may not be able to, you know, completely figure out if that's the largest one that goes in all 3 of them. But at least you can check to see if this actually goes in them. Okay? That's greatest common factor. Now, welcome to Math 10. We are going to do more than one concept a day. Okay? It would be nice if I said, okay, that's all we're doing today. Work on greatest common factor. We'll do something else tomorrow. But if we do that, we will need 140 days to complete this course. And we only have 90. So now I'm going to confuse you and show you something else. Okay? lowest common multiple. It's related, but they're entirely different. Okay? Multiple. Multiples of 6, well, times it by 1, times it by 2, times it by 3, so on and so on and so on. Those are multiples of 6. Okay? Multiples of 8, times 1, times 2, times 3. Okay? So when we get a pair of numbers, we want to know what are the multiples that are common. Well, those are common. Okay? These are common. But now I don't want the greatest. I want the lowest common multiple. Okay? What's the lowest common multiple between 6 and 8? It is 24. So we're still going to prime factorize, but now our procedure is a little bit different. Okay? Because greatest common multiple doesn't make any sense. You can always find a larger number that they both go into. Okay? It's like infinity would be the answer, I guess. Okay? So, where are we? What page are we on? State the lowest common multiple of the following. And I don't really have room here to do a tree, but what kind of a tree would I need? Are these both prime numbers? Yeah. What is the smallest thing they both go into? What are multiples of 5? 5, 10, 15, 20, 25, 30, 35. Do we see one that 7 goes into? Okay? Because for that question, there is no greatest common factor, is there? That doesn't make any sense with that question. All right, 10, 15, and 20. Here's a little trick. Okay, there's 2 ways to do this. Take the largest one, because that took a while, and let's see, do these go in it? 10 does, but 15 doesn't. Okay, let's double it. 10 still goes in there. Does 15 go in there? No. Triple it. Now does it go in there? Yeah. 4 times. Okay? So if you really, this is a way to do it, but we're going to show you to use a tree again. All right? So let's not worry about that. To determine the least or lowest common multiple, take all the prime factors and multiply it by additional factors in the other numbers. This is different than greatest common factor. There we found what was common in each group. Here we're going to take all the numbers from one group, multiply it by some of the other ones. So this one here, that's prime factorized. This is prime factorized. That's prime factorized. Take all the numbers in one group. Let's go 2 times 5, okay? And multiply that by additional numbers that aren't already included. Do I have a 2 already? Yes. Do I have 2 2s? No. So I got to multiply it by another 2. Do I have a 3? No. So I got to multiply it by a 3, okay? Now that one's done. Do I have a 2? Yes. Do I have a 7? No. I need to multiply it by a 7. And that's where this came from. Okay? So the lowest or least common multiple of these 3 numbers is 10, 20, times 3 is 60, times 7 is 210. So could we get that by going the way I just showed you? 14, these don't go in there. Let's try 28. They still don't go in there. What's 14 times 3? 42? They still don't go in there. And you go all the way up until you get to 210. Well, that would take a while, wouldn't it? You could do it, but it would take a while. This is a lot quicker. Okay, a couple more. Lowest common multiple of these two numbers, what are we going to do first? Prime factorize. Okay? I hope I'm not confusing you, but let's go backwards. Greatest common factor between these two? It's 5. How do I do that? I find what's common to both two groups. There's a 5 in each group. I'm done. I don't do that for least common multiple. For least common multiple, I take all of the numbers from one group, okay, lowest or least common multiple. Every book says something different. So 5 times 3, and then I multiply that by numbers in the other groups. Here I just have one other group that aren't already here. 5. Do I have a 5 in here? Yes. 7. Do I have a 7? No. So I got to multiply that by 7. Okay? And what's 21 times 5? Or 15 times 7? 105. Again, that's the smallest number that these both go into. Okay? We all confused? Yeah, sorry, but hey, got to do both these today. Okay? So let's do this one. I don't know what to take out of 126. I don't know what goes in there other than 2. So let's just take a 2 out. Let's half it. That's 63. And that's 9 times 7. We just saw this one. 3 times 3. What goes into 441? Who's got good numeracy sense? What do I want to try? Do I want to try 2? No. So let's try 3. Oh, 147. Okay. Now what goes into 147? Do I want to try another 3? Sure. Whoop. What happened there? I don't know. 147 divided by 3 is 49. And 49 is 7 times 7. Least common multiple. Take all the numbers from one group. Just for a change, let's use the second group. It doesn't have to be the left one, right? 7 times 7 times 3 times 3. And then what? I multiply this by all numbers in other groups. Here I just have one other group that aren't already there. Do I have a 7? Yeah. Do I have a 3? Yeah. Do I have another 3? Yeah. Do I have a 2? No. So I got to multiply that by 2, and then I'm done. Okay? So what is that? I don't know. That hurts my head. That's 49 times 9 times, that was a 2, wasn't it? Doesn't look like it in my pen. Wow, 882. That's the least or lowest common multiple of those numbers. But hey, look at that other way I told you to do it. Does this go in there? You try it on your calculator. No. Okay, let's double this one. 882. Does that go in there? Yeah. That way would have been quicker, wouldn't it? Okay? So there's a couple ways to do this. Okay, we're not done yet. Perfect square. How are we doing? Lots of time. You remember what a perfect square is? These are perfect squares. Why are they perfect squares? Because they're nice to take the square root of. If I take the square root of 49, it's a nice whole 7. If I take the square root of 36, it's a nice whole 6, and so on, and so on, and so on. These are called perfect squares. What's the square root of 1? 1. Okay? There is a number multiplied by itself that gives these. In this case, it's 6. In this case, it's 7. That's what a perfect square is. Okay? Don't worry so much about this. All it's saying is, 4 times 4 is 16, but negative 4 times negative 4 is also 16, isn't it? Okay? So every square root has two different answers. Okay? Don't worry about it right now. All right. We're dealing with whole numbers. Why are we talking about this? Because we're still doing prime factorization. Okay? It's included. Complete this. These are perfect squares because I can take the square root of these and it's something nice. Right? This is 3 times 3. This is, they've already started this for us. They want to take a 4 out of there, so it looks like I've got to have a 9. And 4 is 2 times 2. 9 is 3 times 3. So 36 is 2 times 2 times 3 times 3. Maybe we're going to see a little pattern here. That's 7 times 7, of course. 64. 8 times 8. That's one option. These aren't prime. Keep going. 4 times 2. And that's 2 times 2. Right? Both sides. So 64 is 2 times 2 times 2 times 2 times 2 times 2. Do we see a kind of pattern here? Because if you don't, I will soon tell you. How many numbers, how many prime factors do I have here? 2. How many do I have here? Or 2 and 2. How many do I have here? 2. Is this 3 sets of 2? Okay. If you saw it, great. If not, we're telling you. Prime factorization of a perfect square will always involve factors that occur in pairs. Those are all pairs. Okay? If prime factorization does not result in factors of pairs, then we know it's not a perfect square. Now, why wouldn't you just pull out your calculator and see if you can take the square root of it? Well, because this might not be a calculator question. It might be a no calculator question. Is this a perfect square? If you know the answer, don't say it. How could I find out? Can you take the square root of it? Well, what if you don't know? You don't have a calculator. Then you prime factorize this. What goes in there? 5 times what? Work. There we go. Ooh, 25 divided by 5 is, looks like 45. Okay? That is 9 times 5. That is 3 times 3. Are these all in pairs? Then that's a perfect square. What's the square root of 225? Anyone know? No, because we don't do up to 15 times table. You only go to 12. If I would have wrote 144, you would know that's 12 times 12, right? 15 times 15 is 225. That 225 is a perfect square. Okay? You guys know if that's a perfect square or not? How can we find out? How can we cheat? Well, can I take the square root of it? Guess what the answer is going to be? Yes. Because 210 times 210 is 44,100, there is a number multiplied by itself that equals that, then this is a perfect square. Okay? I'm not going to worry about prime factorization. I think I've yapped too much. Okay, do I need any more? Yeah, let's just do one. How do we find out if this is a perfect square? I'll just do this, okay? We prime factorize it. Do I want to take a 5 out, or do I want to take something bigger out of this? Let's try 25. How many times does 25 go in there? How about 49 times? Does that look like a perfect square? Yes, it does, because I have all pairs. Okay, how else could I write this answer? I got to show you this, because this is how, on the government exam, they're going to write this. If that's a multiple choice question and they say, what's the answer for the prime factorization of 1225? This isn't going to be there. 5 times 5 times 7 times 7. This is. We know this is the same thing, right? Yeah. 25 times 49. Well, there it is. Okay. Okay? We talked about perfect squares. You did square roots before. You have not done cubed roots. Perfect cubes, it's the same thing. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So the cubed root of 27 is 3. Okay? I'm just wondering if I can save a little bit for Monday. I think I will, okay? Let's kind of call her quits there. I'll talk about cube roots again Monday. Come on, Ben. Let's start this. So 1 to 3, A, C, E, all of 4, all of 5. And guys, you're going to want to write this down, right, Sarah? Uh-huh. Huh? What? Don't worry about that. 6 and 7. A, C, E. 8 and 9 to 12. Pretty picky with my questions here, aren't I? Okay? Welcome to Math 10, guys.